All right, here we go. Solving systems of equations by substitution, part 3 of 3. In other words, I've done the easy, the medium, now we're to the hard. I'm hoping that you'll see that it's more long than it is hard. All right, you ready? Here we go. A reminder, we're looking for solutions, and the solution to a system of equations is what x and y equal to make both equations true. So I have 3 steps, and I've set them up here. If you're taking notes, I would suggest doing the same. But I want you to look at the 2 equations, and you'll notice that not one of them is solved for x or y. See, I boxed it out so you can see. So what do? Well, I have to add another step to what I did in the part 2 video. The first thing I'm going to do is I am going to pick one of those 2 variables to solve for either x or y. And what you might notice is that both of those equations will very easily be solved for y. So what I'm going to do is I'm going to just take that first one and put it in step 1. And so I'm going to write that equation. And to get rid of that x, I'm just going to add x to both sides. This is why we teach you literal equations. And now I have y equals x plus 3. And I'm done with step 1. Now, my first equation is written so that one of the sides is either an x or a y. All right, step 2 is identical to what we did in part 2. I'm going to take the other equation, so 3x plus y equals -1. I notice that y is here, and I'm going to put what y equals right here. And so I'm going to say 3x plus x plus 3 equals -1. I don't really need those parentheses. I'm going to just simplify. So 4x plus 3 equals -1. Subtract my 3, and I get 4x equals -4. Divide by 4, divide by 4. I'm running out of room. But x equals -1. All right, step 3, I'm going to take that first equation that I modified, and I'm going to say y equals x plus 3. And then I'm just going to put in what x equals, the -1 plus 3, y equals 2. And so my final answer, and I'll just put it up here, is -1, 2. And I'm also going to, in my head, put both those numbers into the equations to make sure they are true. Now, I'm color coding really on purpose here in the step 1, 2, and 3 boxes. Basically, step 1, I've taken one of the equations, and step 2 has to have the other equation. If you use the original equation, the same equation in step 1 and step 2, you're going to get a special of infinitely many solutions, and in this case, that wouldn't be true. All right, let's go do another one. I'm only doing 3 examples in this video because I'm basically doing the exact same thing over and over again. All right, as you look at those 2 equations, which one would be the easiest to solve for either x or y? Well, hopefully you see that the second equation would be very easy to solve for that x. So that's what I'm going to start with. I'm going to do x minus 2y equals -6. I want to get the 2y away, so I'm going to add 2y to cancel it out, but I'm also adding 2y over here. And then I get x equals 2y minus 6. And so this equation has now become x equals 2y minus 6. Now I'm back to, again, what I taught you in the part 2 video. I'm going to take this x, what it equals, I'm going to put it right here. And so I'm going to take this, I'm doing lots of lines here, hopefully you follow me, and I'm going to put it right here. All right, let's see how that plays out. Okay, so 3 times 2y minus 6, because that's what x equals, plus 5y equals 26. I'm going to distribute first, so 6y minus 18 plus 5y equals 26. Combine like terms, 11y minus 18 equals 26. All right, now it's just a matter of solving a 2-step equation, and I'll get 11y equals 44, divided by 11, so y equals 4. And now step 3, I'm going back to the equation that I had created, this x equals 2y minus 6. So let's go ahead and put the 4 in there, so 2 times 4 minus 6. x equals 8 minus 6, which means x equals 2. Final step is to write my solution where I have my x value first and then my y value. All right, let's do one more. Okay, notice on this one that not one single term is an individual x or individual y. So I'm gonna have to do a little bit more solving. I'm looking at the second one, and I notice that every single one of them has a 3 or a -3 in front of it. I think that's gonna be easier. And what I'm gonna do, it doesn't really matter which one I choose. I'm just gonna solve for this x, just to let you know what I'm doing. All right, so I'm gonna do 3x plus 3y equals -3. I'm gonna get rid of the 3y, and I'll have 3x equals -3y minus 3. And then I'm going to just divide everybody by 3. Remember, if you divide every single term. And I'll get x equals -1y, or just -y minus 1. And so this equation right here now becomes simpler. X equals -y minus 1. All right, next step is I know that this x is going to go here. And so this right here is going to go right up here when I write it. So I'm not going to do my arrow. I'm going to do I'm just going to write -3x minus 4y. Sometimes it's good just to rewrite the problem so you really can see it here. Now I'm going to put this where x is. So -3 times -y minus 1. Then minus 4y equals 2. I'm going to distribute. That's going to come with positive 3y plus a 3 minus 4y equals 2. Combine my like terms, I'm going to have a -1y, or y, plus 3 equals 2, minus 3 minus 3, y equals -1. Well, that means that y equals positive 1. All right, last step is I'm going to go back to the equation that I created, rewrote for this one. And then I'm going to put the 1 in there for y. So x equals -y, so -1 minus 1. X equals -2. All right, finally, don't forget this. I have to write my solution of -2, 1. All right, that's it. Now it's your turn to go practice. Have some fun.